Hello and welcome to episode 124 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. We had a great time a couple of episodes ago when we did the hot questions, so I thought let's do some more of them. The first one then, a contentious one, tabs or spaces and why? Clearly tabs because it's fewer characters. End of discussion.
Clearly spaces because it's more control. End of discussion.
If we're talking about the code on disk, I say tabs because fewer characters. If we're talking about the code in my editor, I don't want to have to care. I want something to care about that for me, so I just hit save, and it formats every time I save, or it even formats as I type. That would be awesome.
You know what very much does care, though? YAML. YAML very much cares.
I hate YAML.
That's why I hate YAML. Like, why would you have anything that cares about spacing?
That's not even the biggest reason to hate YAML.
No? I mean Norway? Or did I mean false? I don't know.
Oh, I don't like hating on technologies, but sometimes you have to make exceptions. All the people who invented it, I really value your work, but I don't want to use your thing.
Is it the case that YAML should never be written by a human?
YAML's designed to be written by humans.
Yeah.
Why does it care about spaces and stuff then? That makes no sense.
Because it's trying to be really well-defined, but also be the natural thing that you would type as a human if you weren't being really well-defined. And those things are fundamentally incompatible.
I just can't fathom it.
Yeah, it turns out having like invisible control characters that have semantic meaning was a bad idea because they're invisible.
Yeah, so if you type 3, then that is going to get treated as a number, even though it might be in a field that normally takes a string. And it just doesn't work as an idea.
So, Andy, you have not weighed in on the great debate.
So it's good that we entered a truly controversial topic, which is YAML. But on the controversial topic of tabs versus spaces, the correct answer is, in an ideal world, it would be tabs, but we don't live in an ideal world, so it's spaces.
You fence-sitting bastard.
Because basically, tabs never look right if you open the document anywhere. So you can't have nice things, and you should just have spaces. But really, I think Amalith's right, that your programming language should have a standard way of formatting itself, which means it completely ignores any irrelevant stuff like spacing that you type in and just looks the same for everyone everywhere.
The argument for tabs that I've heard that I actually do agree with is not the disk space argument. I think that's a silly argument from 1960.
Sure.
It's the argument about screen readers and accessibility, that the tab character is better handled in screen readers, right? Where instead of, I guess, a screen reader saying space, 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 something along those lines, it better handles the tab character. Now, I also personally think that maybe we could just have the screen reader better handle multiple spaces together. Yeah. So while I do agree that that is a compelling reason to use tabs, I think there are other ways around that as well that have the benefits of both.
All right. Are you an imposter? As in, do you suffer from imposter syndrome to any extent?
Yes. I feel barely competent, but I keep bumbling on and seem to be doing pretty okay.
I very much also feel the imposter syndrome aspect of it, and I always have. I think I have a non-standard background when it comes to computer science and how I got into development. But even beyond those cases, I eventually once had I guess it was my manager, I'm not really sure. He sat me down and was like, why are you always kind of preface a lot of the things that you say in our engineering meetings with, maybe this isn't correct, or you're always trying to preface it with something. And he's like, I've noticed this about you. He's like, are you worried that you're not doing good? And I was like, almost broke down. Like, absolutely. I don't think of the same caliber as all the other people that I'm working with. And he was like, scratch that. You are absolutely an amazing developer. Now, he could have been like trying to make me feel better. I don't know that I would categorize myself as amazing, but just hearing that from somebody else, especially somebody in somewhat of a position of power above me, that started to it put the cracks in the imposter syndrome armor that I put on all the time. So I always try to think back to that. That doesn't mean the armor's broken down and I don't have it anymore. I still think about it frequently, but having somebody verbally tell you like, no, you are good at this. And that can make such a big difference.
I absolutely feel like an imposter. I walk into work quite a long way from the station and I can feel my anxiety rising as I walk towards the building, because today might be the day that people work out I can't do this and I'm useless. Or it might just be the day when I fail to do the thing I need to do today and people will realize. And so I just want to encourage anyone listening who feels like that other people feel like that, but also be encouraging to the people that you know, like what Kevin was describing, even if they seem like they don't need it. They probably do.
Another thing that really helped me with this is to think about the fact that in software engineering, just the profession, we always see the final output with all the polish when you go in to do the review or when you're watching some release of some amazing new software. You're seeing the final output. You're not seeing the person re-Googling how to fold an iterator or something silly. Like you're not seeing all of the mistakes that they made, all the typos they made. You're just seeing the final product. So in software engineering, especially, it's really, really hard to know that like, no, that person that I really idolized, they went through the same struggles that I went. They forgot that's actually a pointer in direction or something. Like they run through the same things that I do. And to keep that in mind while you're viewing your idols or viewing that code. And that's very, very helpful.
I make videos on YouTube of me like coding stuff up as live. I used to do it live, which was so stressful, and now I do it sort of as live. Sometimes I get stuck, and I make it absolutely clear in the video, like I've stopped recording here and I've gone and figured this thing out and then come back, because I really don't ever want to participate in that thing of you just see the finished product and or at least not pretending.
There's also another really weird aspect of software engineering where during reviews or just when looking at other people's code, there's almost never a point where being critical of the code is detrimental to your career. Now, that sounds awful. That sounds terrible, but it's the sad reality that, like, if you look at some code, you can always criticize it and people are like, oh, that's interesting. That's awesome, and you also very rarely have to back up that criticism with like actual fact, like make the change that you just said and prove that it worked. So there's a lot of like hypothetical stuff. When people are critical, it puts them in a really weird position of power over the person who wrote the code. So there's these really weird aspects of software engineering in general that I think lead to all of this imposter syndrome. So I think just keeping all of those things in mind and realizing that like other people are feeling the same thing, even people that you might idolize, is the best way forward.
And I would say in any aspect of life, if you find yourself with no imposter syndrome, that's when you should be worried. Clearly something is wrong if you have not even slight pangs of it.
Absolutely. But I would also say that it can be a real serious problem, right? It can be paralyzing. So like fighting against it by reminding yourself, oh, last week my manager said I was doing a good job, or, so-and-so was really impressed that I got that thing working, whatever. Like, it's really important if it's paralyzing.
And you can use imposter syndrome to your advantage as well. So if you feel like an imposter, you can ask yourself why. What are the areas that make you feel like an imposter? And you can also try to improve those areas. That doesn't mean that those areas necessarily need improvement. They might, but they also might not. But improving any area, whether or not you need it, is helpful both personally and professionally. So like use that imposter syndrome to better yourself or find areas just being self-critical. That can also be beneficial, so long as it's not taken so far that it's detrimental to your, physical or emotional health.
Also, if you've got someone you trust and today's a day when you're really feeling it, then let them know and they'll maybe encourage you.
So we're all imposters.
Yes.
All right. Why does software get heavier and heavier every year? Every year, new hardware comes out that's faster and faster and faster, but nothing ever feels faster. And then when you go back to old hardware, new stuff feels really slow. Why?
I think there's a multifaceted answer to this. Like one of it is things get faster, so people are allowed to go about it the more brute force, slow way without necessarily caring. 2, developer machines are like usually pretty quick, whether you're developing remotely on some super beefy server or even locally on a massive desktop or very, very fast laptop. So developers are not usually incentivized to test on super slow hardware because that would slow down the actual development. So there's that aspect. There's, I think, the aspect too that like managers or just the state of the world make us have to like churn out new software faster, and that necessitates cutting a lot of corners. And a lot of those corners are like, I can waste a few milliseconds here. I can waste a second here and just put a loading bar. That'll be fine. So I think there's a bunch of different levels to this.
Another level is layers and layers of abstractions, each of which introduce a performance penalty.
Yeah, and I think part of that moving fast means you don't necessarily take the time to dive down through those abstractions. It's always easier just to lay down another layer of abstraction on top of it.
The first example that comes to mind is some of the architectural decisions behind our last consulting client's front-end application. First of all, they were using a web framework, of course, but then they had a bunch of frameworks on top of that, and then they had their functions on top of those frameworks, and like deep in the stack, it took probably a week or two of a coworker and I debugging. We had to dig in deep and find somewhere where there was some loop that effectively DOSed the database. But it was behind all those different layers.
I think there's another aspect to this. If you talk about a particular piece of software, why does that get slower over time? It's basically because as you change it, especially as you add features, you just add more. It's very, very rare that you have a requirement that you need to remove a piece of your software.
Have you not used GNOME before?
Well, maybe that's where that philosophy comes from, that they got sick of this thing. But yeah, like almost everything that you want to do, every time there's a feature request, it's to do another thing. And normally that means adding more code. Quite often it means adding a new level of abstraction, actually, to make it possible to do both the old thing and the new thing. So yeah, you just end up with more and more over time. And that is probably one of the reasons why people are so keen to rewrite stuff, because there's that sense that maybe we can go back to the time when it was small.
But in true software engineering fashion, usually when we go back to rewrite it, we lose the few performance benefits that were hard-earned over time and experience. And so we lose the performance benefits, and sure, maybe now we're one abstraction layer less, but don't worry, we're going to add a new one to that shortly.
Yeah, because we've lost some critical feature, which is why we had that layer of abstraction.
What's the joke? That the only problem another layer of abstraction can't solve is the problem of too many layers of abstraction?
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to linuxdevtime.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy, 2.5 admins about system administration, Linux Matters for upbeat, family-friendly adventures, Linux After Dark for silly challenges and philosophical debates, Hybrid Cloud Show for everything private and public cloud, and Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too, at linuxdevtime.com/support. All right, what is the correct length of a function?
However long it needs to be to do the thing it needs to do. I think shorter functions are better. I think the max should maybe be a few pagefuls or something like that. It's fuzzy.
I just died.
Pagefuls?
Page as in like screenful. I don't want to scroll a mile just to read the function body.
I tend to think about a page full is about the max. That's not to say I've never gone over it. I definitely have. And definitely when programming in Rust, which does not like things like split borrow. So you end up just putting everything in one function. So like there are cases like that. However, I would say if you're at a page full, you should be evaluating how to make that less than a page full. And I typically I enjoy when it's about a half a page. Mm-hmm. That way there's enough code in there that it's doing something I think useful. It's not just a getter or a setter. And I can potentially fit 2, even possibly 3 functions on the screen at a time for a standard like horizontal monitor.
Yeah, interesting. Rare downside of Rust that sometimes it's hard to factor out a function from another function in a way that in most languages is trivial. Yeah, the correct length of a function is less than 10 logical lines of code.
I was literally just thinking about the linter warning I got this morning from Rubocop saying your function is too long. It is 11 out of 10 lines. And that was so annoying. There was no way I could make it shorter. I just had to silence that warning for that function.
So yeah, I'm not saying I've never written a function longer than that. That's obviously untrue. I've written and contributed to functions that are thousands of lines long. Although I wouldn't say I've written them, but I've definitely worked in them. And it's a nightmare. And if it gets over 10 logical lines of code or thereabouts, then I am looking for ways to break that up and give each part a name so that I have some chance of understanding what it does later. And even better, finding a way of breaking it into like chunks that have separate variables and separate meanings so that their name is easy to state and easy to understand. And they become independent units that I can test separately. And then I'm in my happy place.
I think there's a closely related question of how long should the ideal file be? Do you prefer longer files but fewer of them with many functions all in them, or do you prefer many files that are all very short with very few functions in them?
I mean, I think you can probably guess what I'm going to say, and it's many small files, each of which has a unique name so that I can jump to it easily. And a rare positive comment for Java. I think Java got it right, that each class or each kind of unit of stuff should have its own file. Why not? Why not make it easy to just jump to the thing you're thinking about?
I very much agree. That's the way I tend to prefer breaking up my projects, is smaller files, but more of them, where I can independently name them and jump around between them much easier. I find that an easier way to logically separate things out. But I have worked in projects that'll have like one massive, massive file and that's it.
I hate the ones that are just a massive file. I generally prefer more smaller files as well.
And another black mark against Rust, that quite a lot of Rust projects tend to lump quite a lot together in one file, and they tend to put the unit tests in the same file as the code, which can be good and can be bad, but it does make for longer files.
I would say the Rust standard library actually does that quite a bit, but they also have very, very, very tiny functions. A lot of their functions are 2 or 3 lines long.
I prefer more smaller files, but I don't want them all dumped in a lib directory. I want some sort of hierarchical organization so I can know, okay, this is a package. The files in this folder are related to this package. So anything in here might be what I want if this is what I'm looking for, rather than just spewing everything in one folder. And I have to know exactly what I'm looking for, rather than being able to find it myself.
Absolutely. But then related question, Amalith, what is the correct maximum depth of a hierarchy, or can it be any depth?
The breadcrumb should not require an ellipsis. How about that?
That sounds like a poem. I'm kind of inclined to say the correct depth is 2, right? There should be like one level of sub-chunking inside your main chunk.
I think I tend to go much deeper than 2, but usually try not to go beyond something like 5.
Definitely shallower, better than deeper.
I think we should just stick with the breadcrumbs should not contain an ellipsis. I just love it.
All right. What should every programmer know?
If there's no test for it, how do you know it works?
Because you ran it and it worked. It was fine.
There's a really good blog post, and I think also a video or demonstration on what, like, the numbers that every programmer should know. And this has to do with like the relative speeds of things like a register or an L1 cache versus L2 cache versus L3 cache versus main memory versus disk access versus network access. Keeping those somewhat relative speeds in mind, I think, is very beneficial. Now, I will also say, like, for certain subclasses of programming, it's probably less beneficial, but I think just knowing those things and knowing how dramatically different they can be is helpful to know, no matter what level of the stack you're programming at.
Yep.
Plain text is no longer just ASCII. You must understand some bare minimums about Unicode to be a programmer working with strings.
That sounded like you were reading that, Emily.
No, I came up with that after reading the title and description of the post I read it from. The title is the absolute minimum every software developer must know about Unicode. And it talks about many of the crazy things I just had no idea Unicode supports.
I'm sure I've plugged it before, but I've made a video about character sets called Interesting Characters, which it talks about some of the Unicode stuff, which might be an interesting introduction. I was surprised how interesting it is. That's why it's called Interesting Characters.
This is one of my favorite, maybe not favorite topics, but it is a favorite topic of mine when people are getting into Rust is, why do you have like 14 different string types? Like, what in the world is going on here? And it's usually interesting to explain to them why all of them exist and why they all have their benefits and pros and cons, because strings are very, very hard.
Yeah, and on the topic of things being hard, another thing that programmers probably need to know is that there's quite a few things that are hard. And when you hear about them, you should probably use a library that someone else wrote or be very, very careful. So those include people's names, which are surprising in many ways. They are dates and times. They are interacting with your operating system, including things like file names, which can be all kinds of weird stuff you weren't expecting.
Cryptography is probably another really big one.
Cryptography is hard, but I think people probably know that already, right? I don't know, maybe not. Floating point numbers are hard.
Randomness is hard.
Lots of things are hard.
Well, the one thing that every open source programmer should know is that you are appreciated, even if it feels like you're not most of the time.
Wow, that's beautiful, Joe.
Thanks. Right, well, we better get out of here then. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.